Okay, it's 11:45. One hour, 32 minutes into the test. Water temperature. Room temperature. Hypertek pack. CoolZone pack. Okay, it's 11:54. $141 into the test. Water temps bouncing between 94 and 93.9. Hypertek pack. CoolZone pack. Room temperature is about 104. Okay, that's 151 into the test. I can't tell, looking through the viewfinder in this camcorder, and I'm not there. I think we've got an image there. Water temperature, room temperature, Hypertek pack, CoolZone pack. Okay, it's 12:17. 2 hours, 4 minutes. Water temperature. Hypertek pack. CoolZone pack. Room temp. Okay, 12:32. So we can get that. 2:18. All right, 94 water temp. Room temp about 106. All right, we jiggled both of the packs a little bit, try to get some of that ice moved around. Hypertek pack 70 degrees. CoolZone 73, 73 and a half. Okay, it's about 12:45. $231 into the test. Again, water temp is pretty steady. Room temp's about 106. Hypertek temp. CoolZone temp. Okay, it's 12:54. 2 hours and 40 minutes into this. Water temperature steady. Room temperature about 106. This is the Hypertek pack. This is the CoolZone pack. And what we're going to do, we're going to go ahead and terminate this because the delta T isn't large enough after 80 degrees to really get effective body cooling. That is to get an effective flow of heat from the body cavity to the cool vest itself. Going to go ahead and show the setup just to make sure that to let you know that there was no way we could manipulate this thing. The garments are taped directly to the aquarium, so you know, there's, like I said, there's just no way that we could have pulled these packs out of the garments or anything like that. Let's go ahead and go around and show you the Hypertek pack. Working in a small room here, and I've got my battery is not is dead in this camcorder. Haven't used it in about 4 years. So anyway, well, that's it, and I'm going to go ahead and pull these packs off, and we can take a look at them and see the quantity of ice that's remaining. Okay, it's 12:58. $2.44 into the test. Hypertek. CoolZone. And we're going to go ahead and remove these. Packs so we can see what remains. I'm trying to videotape this all at the same time, so okay, if you're not nauseated from that camera bouncing all over the place. All right, you can see we still have a little bit of ice left. Let's see, there is a little bit of slush left in this. But what we think Brian's doing is utilizing a blend of materials, octadecane and tetradecane. The octadecane has a melting point of 85 degrees, and or a freezing point of 85 degrees, I'm sorry, and the tetradecane has a melting point of 42 degrees. So what can happen is you can have an average melting point of 50 degrees, but you don't have a homogeneous solution. It basically would be like mixing a bag of basketballs and baseballs together and shaking them up. You're still going to have basketballs and baseballs. With the chemical itself, with the blends, you're not going to get, you might get an average melting point on paper of 50 degrees, but you're actually going to have product melting above 42 degrees on the tetradecane side, and on the octadecane side, once it reaches above 85 degrees, it's going to start melting. With the 65 degrees, you have a big enough delta T to still get that flow from the body cavity to the cooling vest itself, but the ice will not melt as fast simply because you have a 65 degree melting point. Once the fluid starts getting hot in this pack, you're getting a conductive heat transfer instead of a convective heat transfer as well, which means that as the liquid heats up, that whatever is remaining is going to melt at a more rapid pace. Obviously, there's a lot more tetradecane in here than there is octadecane. That's why there's just a little bit of slush left. So I hope this helps, and I'll be forwarding this to you shortly, and if we have any questions, please give me a call and we'll discuss. Thanks a lot.